Geometry in chemistry refers to the shape of molecules in three-dimensional space. Molecular geometry is described as the 3D arrangement of atoms in a molecule, normally relative to a single central atom. Whereas, electron geometry is the 3D arrangement of electron pairs around a central atom, whether bonding or non-bonding. A lone, non-bonding pair refers to a pair of valence electrons that are not shared with another atom in a covalent bond, while a bond pair is a pair of electrons present in a bond. It is well known that the electron pairs, being negatively charged, repel each other. This repulsion causes the electron pairs around the central atom to arrange as far apart from each other as possible. This minimizes the repulsion. Under the influence of a single nucleus, a lone pair offers more repulsion than a bond pair which is influenced by two nuclei. This causes a slight decrease in bond angles, angles between bonds or bond pairs. If all of the electron groups are bond pairs, no lone pairs, the molecular geometry and electron geometry are the same. An example is a methane molecule, CH4 with 4 bond pairs and no lone pairs. All 4 of carbon's valence electrons are bonded with hydrogen atoms. Its molecular, as well as electronic geometry, is tetrahedral. An example with differing molecular and electron geometries is that of ammonia, NH3. With the central atom nitrogen having 5 valence electrons, it possesses 3 bond pairs and a lone pair of electrons. Its molecular geometry is trigonal pyramidal while its electron geometry is tetrahedral. Difference between molecular geometry and electron geometry. Determination of electron geometry. Since electrons are always moving and their paths cannot be accurately figured, the arrangement of electrons is described in terms of electron density distribution. Electron geometry is determined by the number of electron pairs. The following table gives an idea of electronic geometry according to the number of electron pairs. Determination of molecular geometry. The shape of a molecule is determined by the bonded atom, although this does not mean the shape itself is unaffected by the presence, repulsion, of lone pairs. Molecular geometry includes geometrical parameters such as bond lengths, bond angles, and torsional angles that help determine the position of atoms as well as a molecule's general shape. It influences a substance's properties such as its reactivity, color, polarity, magnetism, biological activity, and phase of matter. Various techniques to determine molecular geometry include Raman spectroscopy, infrared spectroscopy, and microwave spectroscopy. Axe method. Axe method is an efficient tabular idea to represent molecular geometries. A represents the central atom, each X represents an atom bonded to A, or bond pair, and each E represents a lone pair on the central atom. Below is the table of molecular geometries, arranged for different electron pairs. Key takeaways.